Thanks, Scott. So yeah, like Scott had mentioned, my name is Markos. I'm a product development engineer here at Ford. I'm one of the lead developers on the AppLink SDK. I've been in software and technology for a number of years. You know, my roots come from automotive, but I've also worked in telecom. I've worked in education, and having that kind of a background has allowed me to become kind of a well-versed developer. But outside of that, outside of my work experience, I've always been a hacker, and I think that that's something that a lot of you can relate with. I'm always looking to innovate. I'm always looking to promote technology and use technology to solve our everyday problems, and I think that's something that probably a lot of you can identify with. So that's a little bit of a bio about myself. You know, in regards to the AppLink SDK, I'm going to give you kind of a high-level overview of the SDK. I'm going to give you the building blocks of getting up and running. Later on today, we're going to have a master hacking class. It's important to grab this fundamental information today in this session and apply it in the master hacking class. As a side note, all the content that I'm about to review today, it's available on developer.ford.com. I'll be plugging the website a number of times within the session. Pretty much everything that I'm going to talk about, all the content, it comes from developer.ford.com. You can find it all in the Getting Started guide. So here's kind of an agenda for us today. We'll briefly talk about what is the AppLink SDK. After that, we'll talk about remote procedure calls, what we call RPCs. This is something that we've been talking about time and time again in our sessions today. After that, we'll talk about some fundamental building blocks in regards to the AppLink SDK and the AppLink proxy. We'll talk about the life cycle of the AppLink proxy, how important that is, what to keep in mind. We'll talk about lock screen management. That's a prerequisite for any app that's approved by Ford. We'll talk about new and existing RPC calls. So we have a number of RPC calls that already exist, but we're always enhancing things, and we'll talk about new ones and how that you can fully utilize those. After that, we'll talk about, just very briefly, registering your app with Ford and how to get started. You know, obviously the downloads and any questions that you might have today. So what is the AppLink SDK? Obviously, we're all familiar, textbook definition, it's a standard development kit, right? But it really does go beyond that. It's available, obviously, within our developer.ford.com website. It's written natively for each platform that we offer it for. So on the Android side, it's written natively in Java. On the iOS side, we have Objective-C. So that keeps the SDK pretty quick, pretty efficient. Basically, at the end of the day, the AppLink SDK heavily utilizes a proxy. This is something that a lot of people have been discussing back and forth. It's something that you may have picked up on already. This proxy is basically a middleman between your mobile application and the vehicle's head unit. And so all communication that happens between your mobile application and the vehicle's head unit is enabled by this proxy. The proxy enables seamless communication between the two. All communication that occurs happens using remote procedure calls, or RPCs. And so say, for example, we wanted to do something very basic. Say we wanted to just display some text up on the head unit's display. What we'd want to do is create our proxy object, perform the appropriate handshaking, and after the user has opted in, we have the ability to build an RPC that uses a show type RPC. What that basically is that we're showing some text. We send that over the line to the vehicle's head unit. The head unit will respond back to the mobile application and say, yes, this was successful, or no, there was an error. And that's kind of a real high-level feel of how RPC communication occurs. We'll go into detail later on within the section. And so obviously, we've been talking about remote procedure calls basically all day long. And remote procedure calls are huge in AppLink. You know, this is really what our APIs are built upon. And so there are different categories for remote procedure calls. There's the RPC request, and that comes from the mobile application. It's sent to the head unit. There's the RPC response that's sent from the head unit back to the mobile application, and there are RPC notifications. And basically, that's an asynchronous event that's occurred. It's something that has happened on the head unit that the mobile application needs to be notified about. And so say, for example, the user's opted into your app. The head unit will come back and it'll say to the mobile application, user's opted in, here's an HMI, a human machine interface status change. There's other important fundamental things that you need to know about each of these different types of RPCs. The RPC request object, it includes a correlation ID. And the correlation ID really keeps that RPC request unique. From an app developer standpoint, you assign that correlation ID to the RPC request. When the RPC request is sent over to the vehicle's head unit, the response comes back with the correlation ID that you sent across. And so that allows you to marry the request and the response, and you can make a determination if your request was successful. So say, for example, we send out 5 show requests, but one of them comes back negative. The way that you're able to determine which one is negative is based on the correlation ID. Notifications, they work just slightly different. There's no correlation ID that's necessary for a notification. Basically because the head unit is sending that to you. It's an event that's occurred. It's saying, hey, guess what? Something happened. You need to know about that. Within the response object and the notification RPC, within both of those RPCs, there will be status codes saying, in the case of the response, it'll say, was it positive or negative? Did I successfully do what you asked me to? In the case of the notification, you'll have some information saying, here's some details about what this information I'm sending across to you. And so continuing on, now that we know a little bit more about remote procedure calls, or RPCs, there are some really fundamentally important RPCs to be aware of. And I've listed them up on the screen for you. The register app interface request, that's the very first RPC call that any app will send out. And so this register app interface request, it includes descriptive information about the app that's trying to register on the head unit. And so just as the name implies, we're registering on the head unit. And so it would include things like the app name, the app ID, the app type, if it's a media app, if there are any synonyms that are involved with this particular app. And so at the end of the day, the register app interface request describes the app. That's one thing that's important to note. The register app interface response describes the head unit. And so when the register app interface response comes back, it will say, hey, was this positive or negative? I guess we have a small glitch here. But in any case, the response for the register app interface will come back and say, did I successfully register you on the vehicle's head unit? And if I did, here's some information about the hardware that you're now connected to. The head unit has these button capabilities. The head unit has this display type. This is information that's vital to your app because it's telling you what type of hardware you're connected to and what capabilities this hardware has. So we talked about notifications in the previous slide in regards to RPCs. A very key vital notification is the on-HMI status change. The on-HMI status change will come back the moment you register an app interface. So after your app has been registered on the head unit, you'll receive back an on-HMI status change of type none, basically saying, okay, you're available on the head unit, but you haven't been activated. You don't have permission to do a whole lot of anything right now. Two other important ones to note are unregistered app interface request and unregistered app interface response. In both of those cases, they're in parallel with the register app interface request and response. So we have made a decision that we'd like to be removed from the head unit. Obviously, an unregistered app interface request occurs. The head unit comes back and says, did I successfully remove you, yes or no? Another important thing to note about this slide is that our iOS and our Android SDKs slightly differ in regards to this implementation. The Android SDK does a little bit more bookkeeping for you, and so when you instantiate a proxy object within the Android SDK, your register app interface request is actually created automatically for you. On the iOS side, when you instantiate a proxy object, you still need to create your own register app interface request and send it across the line. So that's slightly different, but it's very minor. The structures between them are all identical. They're all exactly the same. The same is the case for the unregistered app interface request and response. In the Android lifecycle, that automatically happens for you. So if you exit the app, if the app is closed out, the unregistered app interface request will happen automatically. And so we've talked a little bit about HMI status, that notification that comes back from the head unit saying, hey, you're available right now. The very first status that you'll get back is none. Generally, it's none. There are some cases where you can get a background on newer Sync Gen 1.1 hardware, but for simplicity's sake right now, just consider it always, you'll get a none back. When you receive that none, you're waiting for the user to opt in. When the user has opted in, what that basically means is that the user has said that they want to use your app, either through a voice command. So say, for example, you created a Hello World app, and the user has the ability to hit the push-to-talk button within the vehicle and say, Hello World. Then your app will go into the HMI full level. They also have the ability to use the actual manual buttons within the head unit. And so they can use those buttons to navigate to your app, select it. It'll also go back into HMI full. Limited also works in parallel with full. It's almost the same case. Basically, limited just has, the user has navigated away for a moment. Within the background state, it's basically saying that the user has selected the app, but they've made a change in their decision. So say they switch to the radio. Now your HMI status has gone to background. So as you can see, each of these states, they're important for you to track the life cycle of your app. They're important for you to be able to make decisions about what is available to you within the head unit's capabilities. So the next piece is in regards to AppLink lifecycle concepts. This is, to be totally honest with you, this slide, it's busy. There's a lot going on here. The reason that I included it is we as app developers know that one of the trickiest parts about creating and managing an app is managing its lifecycle. Things can get, especially on the Android world, things can get very tricky when you have services running in the background, when you have activities that can get destroyed at any particular time. The same applies in a less complex fashion to the AppLink proxy. And so this came directly out of our Getting Started documentation. It's within the PDF. It's within our For Developers website. If you get stuck within a certain state, it's important to fall back on this as a reference. And so say, for example, you were interested in knowing what happens when the user exits the app through the vehicle's HMI interface. So we know if we follow this, we can see that your HMI status will become none, and you're waiting for the user to select the app again. And when they do, it'll come back around to full. And so I won't go through every piece of this. I think it's similar to drinking from a fire hose. It's a lot to digest in a few minutes, but it is important that when you develop your apps that you take this into account. So the next piece that I have to talk about is lock screen management. And this is something that has been kind of spoken about from time to time within our sessions today. Lock screen management is very, very important. We don't take it lightly at Ford. It's about keeping our drivers safe. It's about keeping the driver focused on the road ahead as opposed to interacting with the mobile device. We've spelled out all the rules behind lock screen management within the Ford developer website. Basically, to put it in a nutshell, when the vehicle is in motion, the lock screen definitely has to be up. If there are specific cases that you'll need to review within the website and look at all the different scenarios, but when the vehicle's in motion, our intent is to keep the lock screen up so that the user isn't interacting with the device. They should be interacting with the mobile application through the HMI interface, through speak commands, through that type of thing. This at the end of the day, prevents the user from actually using the app while they're driving. And so the lock screen, what it does is it provides basically a lock. There's no functionality available for you with the exception of a logo, and no one's going to really take a big interest in looking at that while they're driving. And so the next piece is in regards to RPC, the RPC overview. We have lots and lots of RPCs. And I won't walk through every single one, but I will give you some examples of each to be aware of. We've talked about how there are different categories of RPCs. The RPC requests and responses work in pairs. The notifications are asynchronous. Those are events that come back from the vehicle's head unit. And so we can look at a simple scenario. Say, for example, your app wanted to subscribe to a specific button on the vehicle's head unit, a physical button. Say you wanted to subscribe to the OK button. We would send across a subscribe button request to the vehicle's head unit. The vehicle's head unit would come back to us and say, was that subscription successful, yes or no? In the case that it was successful, when a button press occurs on the vehicle's head unit, we would get back an on-button press notification. In addition, we would get details about that button press. We would find out, was the button press a short button press? Did they just quickly tap it? Was it a long button press? There is other information that's enclosed within that RPC notification. And so you can start to see how you can use these RPCs in conjunction with each other. Another example would be the add command. Now, say, for example, we had a Hello World type app, and the user selected it, and we wanted to add a command to that app to allow the user to say, hello, universe. And so we can add the command. We can issue an add command to the head unit. The head unit comes back and says, was that positive or was it successful, positive or negative? If it was successful, the user has the ability to select that command within the head unit's HMI, and when they do, you'll receive back an on-command notification. And in that notification, it'll give details about the command that was selected. And then you can display a show command that says, hello, universe. So you can see these RPCs, they all tie together. They're really fundamental pieces of the AppLink SDK. Some continued RPCs. Another important thing to note about this list of RPCs is that we have, within our Ford developers website, Java documentation on the Android side of the house that includes all the RPCs. It includes details about all the information behind the RPCs. It includes what parameters each RPC requires. It includes information about the responses that should come back as well. And so on the Android side of the house, we have Java documentation that details all of this. On the Apple side of the house, on the iOS side of the house, we have Apple docs that detail all of this. So when you go to download the SDK from the Ford developers website, it's important to take note that within that download, there is documentation, and it's helpful to reference. And so we talked a little bit about HMI statuses, the HMI status notification. It's important to note that not all RPCs can be used in every single HMI status. So you can see when your app has an HMI level of full, you can basically do a lot. There's a lot that's available for you. But when things go further out into the background, some things aren't available. And definitely in the none state, very few things are available. And so this is just a sample. It came from the developer's website. There are actually more RPCs that should be included that you can certainly go out there and reference. But again, I just wanted to put a sample in just to make you aware of documentation. And so I've kind of been talking about the RPC exchange throughout this presentation. I think at this point we're probably pretty familiar with the flow, but this is just a simple bounce diagram about how it works. So say, for example, we said we send out a register app interface request. The response comes back. Our HMI status will be received. That next line where it says the user has selected the item via sync, that is when the user has actually opted into the app. Now that the user has opted into the app, we receive back an HMI status of full. And when we have a full, we can start to issue other different types of RPCs that we're interested in. Things like add commands, we'll receive responses for that, speaks, shows, that type of thing. This is basically the message flow within the AppLink SDK. And it's consistent across both Android and iOS platforms. We've added a number of new APIs. These, again, are also RPCs. Things like soft keys, scrollable message slider. You can see the list. Each of these items, I'll give a little bit of detail for them as we walk through the session a little bit further. Because these are new, I wanted to give them a little bit more attention. So soft keys, it's kind of a clever idea in that every head unit, it has a number of buttons. They're fixed physical buttons that the user can select. And we talked about how to actually subscribe to those buttons earlier today. We talked about how you can subscribe to it and you wait for the notification. Well, how about if we wanted to create our own button? That's what we can do with a soft button. So we can create up to eight buttons. We can put the text that we wish in there. And the user has the ability to actually select each of these. The notifications come back the exact same way that they did with the physical buttons. So once you've learned to actually subscribe and to use the physical buttons, soft keys, they come naturally. So scrollable message is another new one. Basically, scrollable message allows us to, as the title would state, it allows us to put a pretty good amount of text into a message. And this is subject to driver distraction in certain areas. We want to be cognizant of our drivers. We need to be careful. When your app is submitted for approval from Ford and it goes through the validation process, we have to be careful about the types of RPCs that we use very regularly. So we wouldn't want to send a number of scrollable messages in a row because, again, that's going to distract the driver from what they should be focusing on. But there are scenarios, there are use cases where having a scrollable message within your application is valid and warranted. Slider is pretty similar. It's another UI type RPC. And so as you can see, it kind of makes it a little bit more visually appealing for the end user. You have the ability to choose where exactly within this progress indicator you would like to make a selection. And so once you do so, obviously the user would hit save in this case, and a notification would come back to the app, and it would say, OK, this is the location that you've saved. This is what you've chosen. There are a number of different uses that this could be applied for. It's more of a clever idea than just displaying a simple line of text to the end user. So audio pass-through, I think, is one of the RPCs that a lot of people are excited about. For the first time, as of Sync Gen 1.1, AppLink SDK 2.0, we have the ability to use the in-vehicle microphone and extract that data and send it, the vehicle's head unit extracts that data and sends it off to the mobile app. So say, for example, you wanted to get some text. I'm sorry, say, for example, you were capturing voice from the user. That voice could be sent across in raw PCM format to the mobile application. The mobile application could then potentially take that audio data and send it up to a cloud service and transcribe it. There are a number of different use cases that audio pass-through could apply, but again, just keeping in mind that you have the ability, this one is actually limited by a permission set, which we'll talk about later, but potentially you have the ability to capture audio data and send it across to the mobile app from within the vehicle's microphone. So push notifications. This ties directly to the alert RPC. And the alert RPC previously wasn't allowed to send a notification from the background. Again, this is an RPC that having a push notification requires special permissions, special policies to be set up by Forward for your app. But basically, at the end of the day, if your app isn't in full, you can potentially still send a notification to the user that's using the vehicle's head unit. And so in this case, you know, an event occurred, and the app might have come back and said, hey, you know, this is something you might be interested in. I'm not in full right now. I don't have an HMI status of full, but this is an important message, and you should be aware of it. So this is one I think that a lot of people are excited about, vehicle data. And so vehicle data, it works just like the rest of the RPCs in a very similar fashion. We have different types of RPC requests that happen for vehicle data. There's the get vehicle data RPC and the subscribe vehicle data RPC. The get vehicle data RPC is an ad hoc request that goes out to the vehicle. Say you're interested in just getting the speed right now. I need to know what the speed is right now. So what would happen is you'd send out a get vehicle data RPC request requesting the speed value, and the head unit would come back and say, okay, here's the value that, that you've requested back. The subscribe vehicle data works a little bit differently. The subscribe is more of a notification-based system. And so when you subscribe to speed, when a change occurs, that's when you actually get back some information. When something's happened, that's when you get back a notification from the vehicle's head unit. There are a number of different categories for vehicle data. Things like vehicle information that has things like fuel level, fuel economy, odometer, VIN. There are driving characteristics that have driver braking, seatbelt status, gear position, RPM. There's vehicle location category that includes both the GPS and speed. All of this information, like I had mentioned, is definitely available within our Ford developers website. When you access the Java docs, it actually explicitly mentions each of the items within vehicle data. And in addition to that, you know, I'm looking forward to working with you folks today for the hack, and hopefully we can provide some additional insight in utilizing vehicle data. This is another RPC that is actually, it's regulated by our policy system. And so you do need to have special permission in order to access vehicle data. And so the next piece is in regards to planning for the future. We've talked about a number of different RPCs. We're actually regularly enhancing our RPCs. So things like our add commands, our shows, that type of thing, these have all recently been enhanced to include graphics. And so it used to be that when you sent a show command across to the vehicle's head unit, only text would come across because that's what was supported by the head unit. But now that head units are improving, AppLink continues to improve with them. And so things like graphics can also be referenced. And we have a number of different RPCs that actually utilize graphics. And at the end of the day, it makes for a more pleasant user experience when you can show text with a graphic next to it. It's just more friendly. So another example of that is actually setting the app icon. So we've looked at SDL Core earlier. Kevin gave us a demonstration of that. In this case up here, we're looking at SDL Core, and there are a number of different apps that are registered. And so we also have the ability, when we register, to set the app icon, which is that graphic that is displayed next to each of the different apps. It's a pretty straightforward process. When we get into our master hacking class, we can explain some of the details behind it, but all of this works through RPC requests. So AppLink policies, I'll just very, very briefly touch on this. All RPCs are basically regulated through policies, but the ones that you need special authorization to use are things like voice pass-through, the audio pass-through that we spoke about earlier, vehicle data, and push notifications. And so when you register your app with Ford, you also need to include the context of the app. How is it that this app is going to be used? If there is a specific use case for things like vehicle data, then you can be granted permission to those items. And then your policy, your app ID will be used to grant you permission to each of these different RPCs. So like we previously mentioned, the way that policies works is that you receive an app ID from Ford. The app ID is actually passed in when you register the app interface with the head unit, and we govern the rights and access to the vehicle's head unit and advanced features